Hello students. In this lecture we shall study about the types of crystalline solids. What are the classifications of crystalline solids? Before I start, I will request you to please subscribe my channel so that all the videos notification comes to you and you don't miss any of my videos. So we start this lecture. What are the classification of crystalline solids? What are the types of crystalline solids? The types of crystalline solids: number one is molecular solid, second is ionic solids, third is metallic solids, and fourth is covalent solids. We shall study these types of solids one by one in detail. First comes molecular solids. The molecular solids are those crystalline solids in which the constituent particles are the molecules. These are three types of molecular solids. One is non-polar, second is polar, and third is hydrogen bonding solids. So we will study these three types of molecular solids. The constituents in non-polar solids, they are atoms or non-polar molecules. Non-polar molecules. The constituent particles of non-polar solids are atoms or non-polar molecules. Examples, we can say that hydrogen, chlorine, iodine, these are the examples of some of the non-polar solids. And forces are weak forces between the constituent particles, because these type of forces between the constituent particles, they are weak and hence they are having low melting point or low boiling point. In fact, they are in the form of liquid or gas at room temperature and pressure, because their melting point is low and boiling point is low. And if we see conductivity, they are poor conductors or non-conductors, because there is no movable charges in these type of, no free electrons and no movable charges in these type of non-polar solids. Hence they are poor conductors or non-conductors of electricity and heat. So this is non-polar. Now we come on to polar solids. Polar solids are constituent particles are polar molecules, and example of these are HCl, sulfur dioxide solid. These are the examples because these are polar molecules, and the forces are polar covalent bonds between the constituent particles, and there is somewhat relatively stronger dipole forces. Dipole interactions are there between the particles. And why I said relatively? Because it is stronger than the forces in non-polar molecules. They are relatively, but not so strong. They are relatively strong, more than the forces of non-polar solids. And again, they are soft in nature. They are soft solids. And if we see non-polar solids, they are also soft. So polar solids are soft. They are non-conductors. Non-conductors of electricity, because there are no charges which are movable in these solids. So they are non-conductors of electricity. Their melting point is higher than that of non-polar solids, and but they are also liquid or in gaseous state at room temperature and pressure. At room temperature and pressure, they are mostly in liquid and gaseous state. And examples are solid ammonia or solid SO2. These are the examples of polar solids. Now we come to another type of molecular solid, that is hydrogen bound solids. The constituent particles of hydrogen bound solids are molecules with hydrogen bonding, like the atoms, molecules containing hydrogen, fluorine, oxygen or nitrogen. These are all molecules of these elements. They have hydrogen bonding between them. So the solids formed by these elements, they are hydrogen bond solids. And in this, the forces are between the particles, constituent particles, is strong hydrogen. They are held together by strong hydrogen bonding. So these are strong forces, and they are also non-conductors of electricity. Non-conductors of electricity, and they are soft by nature. And they are mostly volatile liquids. Volatile liquid state and at room temperature and pressure. If we decrease the temperature and pressure, they will solidify and will make hydrogen bonding solids. So these are the molecular solids, three types of molecular solids. Now we come on to the ionic solids. What are ionic solids? See, ionic solids ionic solids. In these type of solids, the constituent particles they are cations, positive ions or anions. So in the crystal lattice, cations and anions are arranged in three-dimensional space. Now they are bound by strong electrostatic forces, or what we say Coulombic forces. They are hard and brittle. Hard and brittle. Hard because they are the constituent particles are held by strong electrical forces, and brittle, they are broken. They have high BP, high boiling point and high melting point. Why? Because the forces between the constituent particles are strong, and hence to break those forces we require more heat, and hence the boiling point is high and melting point is high. They are electrical insulators. They are electrical insulators. Electrical insulators in solid state. In solid state, they are an electrical insulator because there are no free electrons to move about, hence the electricity cannot pass through. But in molten state, what happens? The ions are free to move. Ions are free to move in molten state or liquid state. Free to move in molten state when they are melted, or when they are dissolved in water in liquid state. They are good conductors because ions are now free to move. So this is type of another crystalline solids, ionic solid, and the third is metallic solid. We will now study about the metallic solid. You know that metals are the constituent particles in metallic solids are positive ions of metals. They are surrounded by a pool of electrons. Each atom contributes to its pool of electrons according to its valency electrons. So the positive ions are surrounded by pool of electrons. They are good conductors of electricity. Why they are good conductors of electricity? Because the electrons are free to move. Electrons are free to move, hence they are good conductors of electricity and good conductors of heat. When one end of the metal is heated, the heat is passed through the surface of the metal through the movement of electrons. So they are also thermal conductors, good thermal conductors. And they are highly malleable and highly ductile. Malleable means they can be, when beaten, they can be converted into sheets and they can be drawn into wires, hence they are called ductile. They are malleable and ductile. They are lustrous. Luster means there is a shine in metallic solids. Why? Because of free electrons. Because of free electrons, there is luster of metal solids. And you all know by in 11th class you have studied that they exhibit photoelectric effect. Photoelectric effect, when photons strike on the surface of metal solids, the electrons are ejected, and that in short we say that they exhibit photoelectric effect. Now the fourth type of solid, that is covalent solids. In this type of solid, covalent solids, crystalline solids, the covalent solids, they are generally non-metal atoms, non-metal solids, they form crystals, and they are very big in nature, big in size, so they are also called giant molecules. These are bounded by the constituent particles are held together by covalent bonds, and these covalent bonds are directional. They are directional, and these particles, constituent particles, are held strong forces by these covalent bonds. Covalent bonds are strong, and they are hard and brittle. Hard and brittle. They are having high melting point. Why? Because of these strong forces. And they are insulators. Example is diamond and silicon carbide. Example of covalent solids are diamond and silicon carbide. And one of exception here is graphite. Graphite is also a covalent solid, but graphite is good conductor of electricity. Good conductor of electricity. Why? And it is also used as lubricant. Very soft. So why graphite is good conductor of electricity? Because of its graphite has a typical structure. See, each carbon is held by 3 carbon atoms, and the fourth valency of a fourth electron is free. That valency electron is free to move, and due to this free electron, the graphite exhibit a good conductivity of electricity. And due to its structure, what is its structure? It has layers structure, and each layer can slide over one another, and by sliding over one another, that makes it to be used in lubricant and in machineries, etc. So these are the 4 types of crystalline solids what we have studied in this lecture. And before I finish, I will again request you to please subscribe my channel, so that all the coming videos that will be very useful for your examination point of view, they come to you, and you don't miss any of the videos. Thank you.